Hello, Legacy Sabers, Marsh here. So today we're going to be talking about the rational zeros theorem once more. This is day 2. Today you need to have your notes, the foldable for it, and then a graphing calculator of some nature, either a physical one or one on your cell phone would work as well. The essential question today, how can we solve a polynomial that is unfactorable faster? So last time we looked at the rational zero theorem, we just solved the rational zero theorem by just finding our P over our Q, and we guessed until we got a 0 for our remainder. Now, ultimately, we want to not have to guess and guess and guess and guess and guess. So how can I make it so I do not have to do that? Well, here is today. To find all of our zeros, our steps that we're going to do, we're going to get a hint to get started, and that is the main focus of today. This is the part that we really need to discuss today, is how you get a hint. Then we're going to set our division, find the quotient, factor the quotient if possible, and then find and list all of the solutions that we find. Okay. Now, the fundamental theorem of algebra states that the number of solutions a polynomial has is equal to its degree. Now, for these solutions, we know that can be integers, they can be fractions, square roots, which means they're irrational. They can be double counted so that we can get the same solution multiple times, and even imaginary. So the degree is the highest exponent in the problem right here. Okay, that is the highest exponent in our design. So as we're looking at that, we do need to remember that information. Now, how do we get this hint? To get the hint, you're going to use the calculator. Now, the calculator, conveniently, I have one right here that we're going to be using. Ultimately, you're going to first tap the y equals button. It is right here. And then you're going to be typing into that y equals button the function that we're using. To find that function, you're going to use this x button right here. It's right beside alpha. And then you're going to click graph. We are going to possibly have to change our windows to make that zoom button work. And then we're obviously going to choose an obvious 0 to test with our division. Sometimes for the zooming, we do have to go to option 6, which allows us to get a standard window on our graph. Okay, let's try our very first problem. So first thing I'm going to show you guys is how to use the calculator. So we want to type in 3x cubed minus 2x squared minus 7x minus 2. So I'm going to click the y equals button first, right there, and I'm going to type in our function. So 3x caret key 3, and push to the right. So you got to get out of exponent land. That is something to make sure you do. Minus, now remember you use the subtract sign, not the negative, 2x caret key squared, then get out of the exponent, minus 7x minus 2. Once you get everything typed in, go ahead and push graph. And you should get a wonderful function that looks like that. Now, if your function is weird and out of shape, may I recommend clicking zoom. It's right here. It's right beside window. And 6. Z standard. Z standard means it's a negative 10 by 10, negative 10 by 10 coordinate plane. A normal one that you're used to. Then it'll read graph. Now, what you are trying to find is a hint. You are trying to find a perfect x-intercept. And what it looks like to be is 2. 2 looks to be a perfect number. Now, over here, I do have my graph, same picture. I just have it so that we can see it on our picture there. So what I'm going to use is I'm going to use 2 for my division. So I'm going to set up my synthetic division with a 2 on the outside. Now, this is a degree of 3. So that means I should have 3 answers, which I do, right? On the graph, I have 3 x-intercepts. 1, 2, 3. Those are the 3 things that we'd be finding. On our first day, we did find all of the factors that make a 2 and a 3. So I would do 1, 2, because a 1 and a 2, right? And a 1 and a 3. And then I would say 1/3 and 2/3, and all those are plus or minus, right? That would be our possible rational zeros list. Now, what I'm doing is I'm just getting a quick hint so I don't have to guess and check. I'm going to set up my columns of my synthetic. So I got an x cubed column, an x squared column, an x column, and a no x column. So I'm going to have a 3, a -2, a -7, and a -2. So first, drop the 3. 3 times 2 is 6. -2 plus 6 is 4. 4 times 2 is 8. -7 plus 8 is 1. And 2, look how cool we are. We got a 0 on our first try. It's almost like we knew. It's because we did. Now, I'm going to retranslate this. Since I started at a cubic and I have dropped an x, I have factored out, right? Divided out an x. I'm now at the x squared. So this is technically 3x squared plus 4x plus 1. I now need to factor if possible. So let's set up our factoring. 2 things would be 3x and x. Things to make 1 would be a 1 and a 1. 3x times 1 is 3x. 1 times x is 1x. 3x, both of them positive, will make a positive 4x. So let's set those equal to, put some pluses in there. And then I'm going to set equal to 0. So 3x plus 1 equals 0, and x plus 1 equals 0. So I will get x equals -1/3, and x equals -1. Now, you're probably like, psst, Marsh, you said there was 3 answers. You only have 2. Don't forget about bonus guy right up here. He is also an answer. X equals 2. So those are my 3 answers. Now, looking over here, notice, yep, it's probably -1. Yep, it's probably -1/3. And yep, it's -2. Now, you're probably thinking, Marsh, we have a calculator. Why not just use the calculator? Here's the thing. We want to use the calculator as an assistant, not as the knowledge. Because what if you type in the problem wrong? You want to use the algebra to prove what the calculator is talking to you. Let's try another one. So again, I'm going to bring in my handy dandy little calculator here. And I'm going to click y equals once more. I'm going to push clear to get rid of the one that we just did. And I'm going to type in our problem. So 4x, remember right here's our button, caret key 3, and then get out of the exponent, plus 4x, and then there is a squared button. I always forget about him, but he's right here, right beside the comma, minus x minus 1. And feel free to push graph once you get that. And that is my graph here. Again, zoom 6 is the best way to get the best picture. Looking at that, it looks like it does go through -1. I'm going to bring up my picture here. Does look like we're going through -1. So it looks like we should try -1 on our synthetic. First thing though, I am going to set up my P over my Q, which would be 1/4. So all the numbers that make 1 and all the numbers that make 4. So then my P over my Q, my rational zeros list would be 1, 1/2, and 1/4, all plus or minus. Okay. So setting it up, we said, well, -1 looks like a possible 0. It's in my list, and it definitely looks like the graph goes through there. So I'm going to set it up. I got my x cubed column, my x squared column, my x column, and my no x column. So I have a 4, a 4, a -1, and a -1. So drop the 4, -4, get a 0 there. 0 times -1 is 0. -1. -1 times -1 is 1. Yeah, buddy. Got a 0. Now let's go back to this problem. This is technically now 4x squared minus 1, and we want to set equal to 0. 4x squared minus 1, that is factorable. So I'm going to set it up as a factor because it is both perfect squares, and there's a minus in the middle. So that'd be 2x plus 1 and 2x minus 1. Both of those equal 0. So I'll get my answer when I set them equal to 0, -1/2, and x equals +1/2. And don't forget about bonus, the guy that you used to start it all, -1. Those are my 3 answers. Looking at this, yep, yep, and yep. That looks pretty right. And it was in our possible rational zeros list as well. Now keep in mind, if you start at an x to the 4th, 5th, big high exponent, you may have to do synthetic division twice. Maybe you're going to have to get multiple hints. That's just how the world will work. That is the end of this video. I hope that your calculator and you can get a lot more faster at this possible rational zeros. And the p's over the q's makes it definitely a lot easier than it was last time we talked about it. Until then, I will see you later, Sabers.